Yo, what's up, guys? Welcome to Core Obsessed, and let's start with today's Leetcode Daily challenge. Okay, it's count all possible routes. Okay, I don't know why the question is given hard. I think it's not that difficult of a question, to be honest. If you can understand it, like it takes a very basic amount of DP knowledge. Other than that, the recursion is also pretty easy. So I think it could be a mediumish question if you just understand the basic concept behind the question, and that's what we will do today. Okay, so let's start. We look at the question first of all. So what does the question say? That you are given an array of distinct positive integers, locations, where location of I represent the position of city I, and you are also given integer start, finish, and fuel. Okay. So basically, we are given an array that is locations, and we will be given a start, and this is where we will be starting, and we will be giving a finish, and this is where we have to finish our journey. Okay. And we are also given the amount of fuel we have. Okay. And what we have to do is at each step you are at like a city I and you can pick any city j such that I is not equal to j. Okay, so if we are at a start position, say 0th location, we cannot go to the same location straight away. Okay, and we can choose a city j, and moving from city I to j reduces the amount of fuel by absolute of location of I minus location of j. Okay, this denotes the absolute value of x, right? Okay, and we have to return all possible routes from start to finish. Okay, so yeah, the question's pretty simple. I'll just tell you in, let's say, a easier version. We are given a, let's take the example array 2 3 6 8 and 4. This is our locations array. This is what we are given. Oh, by the way, guys, today I decided to use the lined version. You guys let me know in the comment section down below if you like the lined version better, or like if you like the something like this better. You guys can let me know. Choose the line version for today. So anyway, so yeah, we're given the location array, and we are given the start index, which is equals to 1, a finish index, which is equal to 3, and the fuel, which is equals to 5. Right. So what we have to do is return all possible routes from start. I'll index it up 0 1 2 3 4, and we have to give all possible routes from start to finish. Okay, and we can repeat the locations. Okay, that is a very important point that we need to notice. We can repeat the locations. Okay, um, yeah, it's written here. You are allowed to visit any city more than once, including start and finish. Okay, so what does that mean? We can go from, let's say this is our start, okay, and this is our finish. We can go from 3 to 8, and then we can come back from 8 to 3, and then go back to 3 to 8. That is also a path. So a path could be 3 to 8, and then it can also be 3 to 8, then back to 3, and then back to 8, or from 3 to 8, then to the fourth index 4, and then to 6, and then to 8. We can repeat locations. The only problem is if we have the fuel. Okay, if we have the fuel, we can repeat the location as many times as we want. Okay, we can go 3 8 3 8 3 8 3 8 till we have the fuel in our car. Okay, that is the only different concept in the question. Other than like that, there is like, this is a very basic question. Okay, so let's start with the two test cases that we have. The test cases right here. Okay, so this is the location array, this is the start, this is the finish, and this is the fuel. Okay, so these are the 4 possible paths. Okay, let's check out these paths. So we have a 2 3 6 8 and 4, and 1 2 3 4. Our starting index is 1, so this is our start, and this is our finish, right? Okay, how much fuel do you have? You have 5 amount of fuel. Okay, so let's take the first path. Okay, we can directly grow from 3 to 8. If we directly go from 3 to 8, how much fuel do we consume? Absolute of this minus this, absolute of this minus this. So absolute of 8 minus 5 is equals to 8 minus 3, my bad, 8 minus 3 is equals to 5. How much fuel did we have? 5. So yeah, we can take this journey. So that can be our first path. Let's take the second path. Okay, we have 1 to 2 to 3, right? So if we were to go to first location, and then we were to go to travel to here, 3 to 6, how much is the amount of fuel that we require to travel from 3 to 6? Right, so we need 3 amount of fuel, absolute of 3 minus 6, and from 6 to 8 we need another 2, so that's again 5 amount of fuel. So that's how the paths are there. And similarly, 1 to 4 to 3, once again, the fuel, you can check it out. From 1, we go to 4, that takes 1 amount of fuel, and then 4 to 3, that takes plus 4 amount of fuel, which is equals to 5. Once again, oh, it can be less than 5, by the way. It doesn't have to be equal to 5 every single time. So it can be between 0 to 5. We just have to reach the city, and that's how we increment our answer variable. And the similar way, we have the example number 2. So let's dry run the code basically. What do we have and what do we need? We have our locations array. We'll use the same one, I guess. 4, 3, 1. 4, 3, and 1. Our starting index is 1, our finishing index is 0, and we have 6 amount of fuel. Right. So we'll start from the 0th index, 0, 1, 2, 3. I start from the first index, and we have to finish at the 0th index, okay? And these are the amount of ways we can do. Now, let's think of the solution. So let's take a function solve, which has our locations array, the start location, the finish location, and the fuel that we have right now. Okay. So think of recursion. Okay. Basically, we have to try every single path. Like, okay, we can move from here, we can move from here, or we can move from here, and then we can come back. So basically, we have to try every single path. Okay. And when we have to try every single thing, we can do recursion. That's the simple answer. Okay. Think of recursion. Let's try to think of the base case. Okay. What is the base case? The first thing that comes to our mind is, oh, we reached the the goal of the question, start equal to finish. But if you guys remember, we can go to a city more than once. We can go from finish and then back to start and then back to finish. So this is not really a base case. This is not where the recursion ends. But where does the recursion end? Yes, where fuel in the car becomes 0. Fuel is less than 0. Okay, if fuel is less than 0, we have to return. There's no point thinking about anything else. Okay, so yeah, so if fuel is less than 0, we simply return. Now let's take a variable answer. Int answer equals to 0. If we have reached our location, so if start equal to finish means we have reached our location, we increment the value of answer to plus plus. Okay, so if we are at a location, let's say 0, 1, 2, 3, 4, 5. Okay, so we are at this starting location, right? From here we can go to any of the locations we want to if we have the fuel, right? So for int I equals to 0, I less than locations dot size, I plus plus, answer plus equals to, simply we traverse all the locations, but we cannot go from start to start. Okay, if you guys go back to the question, I'll just head back to the question. Yes, simply written, you cannot move from, you can choose any city j such that j is not equal to I. Okay, we cannot go from I to I. I will come back to the question later. Yeah, so we can't really move from I to I. So that's the condition. So if I not equal to the start location, and if we have the fuel, okay, we can go to any location if we have the fuel to go over there. So and fuel greater than absolute of start minus wherever we are heading. If these two conditions are tick, so if these two conditions come out to be true, we'll be like answer plus equals to, and we'll call the recursion. And at the end, we'll just return answer. Okay, we'll just do this code in the environment and you'll be able to understand much better over there. Okay, I have written like a small part of the code so we can just save time, I guess. Okay, so what we have done is n is equal to location dot size, and then we have just do normal function call. And since the question stated that the values can be very large, so we have to use modulo. So I have defined int mod equals to 1e9 plus 7, which is equals to, if you guys don't know, 1, 8 zeros and 7. Yeah, that's equal to that. So yep, now we'll start with every recursion base case. That's how we start the recursion. Think about the base case. If fuel is less than 0, simply return 0. Fuel is less than 0, like there's no point for going further, right? Can't do anything without fuel now, can you? So yeah, and then we define the answer int answer equal to 0. If we have reached our location, if start equal to finish, then simply answer plus plus. Even if we have reached our location, we have to still continue till we have the fuel. So we don't have to return anything over here, and we just move forward. For int I equal to 0, I less than locations dot size I plus plus. The two important conditions. If I not not equal to start and end, we have the fuel to go from one place to another. And if fuel is greater than absolute of locations of I minus locations of start, right? If that's possible, then we'll do answer equals to answer plus, or answer plus equal to solve of locations. Now we'll change the start to I, obviously, because this is going to be our next starting location. The finish is going to remain same because that is where we have to end. That's our finish location. And the fuel is obviously going to change. Now we have consumed some fuel to go from this earlier start location to now ith location, which is now the next start location. So we have consumed some fuel, which is going to be equal to absolute of, yeah, I'll just copy it, Control C. Yeah, so absolute of location to start location of I, that is the amount of fuel we have consumed. That's that, and we'll just return answer. Looks good to me. Let's run it up once and see if there's any errors. There is an error. Locations. Oh, I missed the spelling. G-I-O-N-S. Hopefully I spelled it right other places. And we missed a bracket. Okay. Now we got that thing fixed. And now yeah, we'll just run it up and see if it works. Yep, it does. And then yeah, it's probably gonna give us a time limit exceed because obviously we have some reoccurring subproblems, overlapping subproblems per se, and we'll have to use DP for that. So yeah, DP is very easy. We just have to do 3 steps. If you guys don't know DP, just watch my previous video. In that I've explained a little bit about DP, but otherwise yeah, we just have to do this 3 steps basically. We take a vector, and with the vector, the dimension of the vector is basically the same as how many variables are changing. We are changing the start variable and we are changing the fuel variable, so a 2D vector. So we are changing 2 variables, so a 2-dimensional vector type int, let it name it dp, and then size will be n plus 1 comma vector int fuel plus 1 comma, let's initialize it with minus 1. Okay. We'll take this, copy, paste, pass it in the function, and then simply that's the first step. The second step is dp of whatever 2 things that were changing, fuel not equals to minus 1. We just return dp of start and fuel. And third step is wherever we are returning something, returning the answer, we just return it as dp of start and fuel equals to answer, and we'll just pass dp in the function comma dp. And by the way, we have, since the solution is supposed to be very large, we have to mod everything. So I'll just mod the whole thing. Mod I have defined mod up here, so you can just use it straight away, and I think that should do it. This whole thing over here. So yeah, where did we write that? Oh, okay, semicolon. And we didn't put dp in here. Okay, a lot of mistakes. There you go. And that should, yep, there you go, accepted. We'll send submit, and yep, it works. So that is it, guys. The question was very simple. You just had to think about the case where it can revisit every single time, so you don't have to return at this point, and we'll just continue our calculations straight up. Okay, so if you guys like the video, please like, and yep, if you have any questions, you can put them down in the comment section down below. Thank you.